Chapter 6, Chemical Reactions. So what is a clue that a chemical change has taken place? Well, chemical reactions often give us some sort of visual signal. They don't always, but a lot of times they do. I've done these slides so many times that I just kind of, it's scary actually. So chemical reactions often give a visual clue, but reactions are not always visible. So we have a list of clues that give us, help us to know if a chemical reaction has occurred. If the color changes, it's a good indication there was a chemical reaction. If a solid forms that was not present there before, if we get bubbles forming, bubbles are evidence of a gas being given off. There wasn't a gas there before, and now there's a gas. That's a change. And the last one is heat or flames. Heat's either being absorbed or produced, or a flame is being produced. And light is sometimes involved in this as well. Light is a form of energy. So you can get energy being absorbed or given off.
Does that just mean it's getting colder?
Yeah, if it gets colder by itself.
By itself?
By itself.
Not like that?
Not like, if you bring something into this classroom, which is freezing today, and it gets colder, that's not a chemical change. It got colder because you put it in a cold environment. But one of those instant ice packs that they sell, and you break the little seal inside and mix it, and it just gets cold all by itself. That's a chemical reaction. The reason it's cold is it's sucking in heat from the outside. It's kind of hard to think about sometimes. What?
It sucks in.
It's sucking in energy, yeah. And it's taking, you're touching it with your hand. Your hand feels cold because the heat energy is leaving your fingers and going into the cold pack.
Yeah, because you don't ever gain cold, right? You lose heat.
Right. Heat and light are kind of, you can't have, there's no such thing as darkness. Darkness is the absence of light. And there's no such thing as coldness. Coldness is just absence of heat. And so there's heat energy which can get moved, and it always goes from a warmer object to a colder object, and it's trying to level out and become equal. You put ice in water, and the ice warms up and the water cools down until they get to be the same temperature. Right? So that the cold pack gets cold, and what it's doing is it's sucking in energy from around it. And eventually it will warm up because it's sucking in all this energy. Where is the energy going? Well, the energy is going into the chemical reaction. It's being transformed from that heat energy into a stored chemical energy in the compounds that are being formed. If you want to talk more about that, I just don't want to confuse people or make your brain hurt too much. So in this exercise, here's a 9-volt battery in a cup of water. You could try this at home if you want to. And what is evidence or the clue that we've got a chemical reaction going on here? Bubbles. There's a gas forming. Where's that gas coming from? Well, the water molecules are being decomposed. They're being changed. Water has 2 hydrogens, 1 oxygen. And what's happening is the water molecules are becoming apart, and the 2 hydrogens are going off, and the oxygens are going off in a different direction. So the evidence here is C, bubbles are present. Let's look at this. So we need a little explanation with this picture. So here we've got this, looks like maybe a pipette with a clear liquid in it. And they're adding this clear liquid to this pale pink liquid. And now it's blue. So this is before, during, and after. So what's the evidence for chemical reaction? Color change. Oh, there's the backstory. So colorless hydrochloric acid being added to a red solution of cobalt-2 nitrate. The solution turns blue. The evidence is the color changing. So here we have a solid forming when a solution of sodium dichromate is added to a solution of lead nitrate. So the picture here, we've got this liquid here, which is yellow in color, but it's clear. You can see through it, right? And here we have what looks like water. Not everything that looks like water is water. That liquid that you measured the density of during the lab exam wasn't water. But when we mix these two, now we get this cloudy yellow stuff. When it gets cloudy, it does so because there are little solid particles and you can't see through solids. And if you let it sit, all those solids will eventually settle down at the bottom. So when you mix two clear solutions, regardless of whether they have a color or not, and they form a cloudy or a milky looking solution, then you know you've got a solid forming. So in this example, a solid forms is the evidence.